This is the Unit 5 review guide for ELR 5.4. Here are the questions for that ELR. The first question says, what kind of energy is heat? Well, remember back to the last unit when we talked about types of energy. Heat is thermal energy. And to be more specific, thermal energy is the motion of particles, which is a type of kinetic energy. Number 12. What is the difference between heat and temperature? Well, heat, that is when particles are moving. It's a type of energy. And when you add heat to something, you are adding energy to something. Kind of like when we did the poker chips in class, you can have more or less of it. It's something that can be given up to another location. I always think of it a lot like money. Temperature, on the other hand, temperature, the best way I think about this is it is just like a molecule speedometer. What it does is temperature tells you the average motion of a group of molecules. So when you take your temperature when you're feeling sick, the thermometer is giving you a reading of the average speed of the molecules and their vibrations after you put the thermometer into your mouth. Number 13. Describe how molecules are moving in the three phases of matter and what that has to do with the amount of kinetic energy / heat that they have. So I'm going to start with solids. Solids are vibrating. So one of the biggest misconceptions is that people think that solids are not moving. They are. They are vibrating in place, but their movement is low. They have no independent movement, I should say. Meaning they can't move around each other because they are stuck together with bonds. Okay, so because of this, they're still moving. What that means is that they have very low kinetic energy. For liquids, on the other hand, have broken free of the bonds that are holding together the solids, and they can move independently. Because they have more energy, they are also vibrating much stronger. They're vibrating faster, and they're moving independently of each other. So they have some movement, but they're still stuck within range of each other. So it's kind of like when we're in the classroom and you're all still in the same room. You've got to stay in the classroom, but you can move around the room. It's kind of like that. So they can move independently, and they have a medium kinetic energy. For the last one, for gases, gases have the most kinetic energy, so I'm going to start that way. Really high amounts of kinetic energy. And they have broken free of all the constraints that solids and liquids face. So they've broken those bonds that keep them from moving around each other. They've also broken the bonds that keep them from staying in the same area as each other, and they will spread into their space. Meaning, if you take some gas and you let it go into a room, it's going to fill that room. If you let that gas go outside, it's going to keep spreading out until it can't spread out any further. Gases have a ton of energy and they keep on moving.